So our today's event is going to be observability in AWS. So before we get started with our event, we are going to learn more about Women Who Code as an organization. So Women Who Code is an inclusive community, and its main vision is to its main mission is to empower diverse women to excel in technology careers, and our main vision is to support tech industry where diverse women and historically excluded people thrive at every level. To be honest, it's been more than 4 years now that I've been working as a volunteer with Women Who Code, and it's an amazing community which anybody can be part of. And I would encourage everybody to be part of our communities and learn more about us with whichever area of technology stack which you're interested to learn, be it blockchain, mobile front end, data science, or anything which you're interested to share with our community, that we would appreciate that. So at Women Who Code, we take the code of conduct very seriously. And Women Who Code is an inclusive community dedicated to providing an empowering experience for anyone who participates in our supports or our community. So we do not tolerate any kind of harassments with our events or online communities. You can always feel free to read the full version of our code of conduct and access our incident report form, which is available at womenwhocode.com/code of conduct. So this is all about Women Who Code as an organization, and I hope that it's clear for everybody. If you still have any questions, please let us know in the chat or Q&A. And before I hand over our today's session to our amazing speaker, Manik Kashikar, I would like to let everybody know that you can always post your questions about the session in the Q&A, so that we can take it up during the end of the session and get your questions or queries clarified. And I'm going to hand over this session to our amazing speaker, who is Manik Kashikar, and who is an amazing friend of mine. She presently works with Thoughtworks and has 18 years of experience into technology space and with different banking sectors. And she has been working with different women in tech communities as well as a volunteer and active participant and also an advisor. So thank you, and please go ahead, Manik.
Yeah, thank you. Thank you so much, Maitreyi, for a warm introduction. Thank you to everyone who has joined the session. Good morning, good evening, good afternoon, and especially to India. I think thank you so much for staying late and being a part of this seminar. Before we start our session on the topic, I would like to really talk about the Women Who Code community. It's an amazing community, and there are a lot of offerings and the foundation ground that this community provides. So I would really urge the attendees, especially the women technologists here, to really join this community and be a part of it, be a contributor here. And yeah, we have a lot to cover today. So, without further ado, I'll get started. Maitreyi, do let me know if my screen is coming up well.
Yes, we can see your screen.
Okay, great. So as we all know, our today's agenda is about the observability, and there are a couple of things I would like to cover as part of this session. It's about why observability, what is the need of it today, what are the changes that we could bring in to improve our operationals and the business excellence. We will deep dive into specifically focused on the AWS tools which are available today in the market for as an observability solution. And then we will also look upon a couple of use cases and the scenarios where we together can work and see what are the various tools and the applicabilities that we can have from the AWS background. Okay, so let's get started. I while we definitely prefer to have any questions being asked towards the end of the session. However, if you see any pressing questions, please feel free to ask it in between, and I'll be happy to take it up. Yeah. So right, let's get started. Yeah, so I'm not sure how many of you have already worked on it. Do you already know about what is observability? Have you already understood about uh, uh, you know what is monitoring? What are the solutions available, etc. But maybe a quick briefer is something that I would like to start with, and let's start it about what is observability and why it is very important in today's scenario. So let's understand it first. I have couple of observations while I work for my client and their enterprise, that with the pandemic effect, I see, today we all are living in a digital world, and we are being influenced by the digital ecosystem, and so is our client and their end users. And that's where I see the focus for our clients today is to ensure that they stand differentiated in the industry by providing a very optimal and exceptional user experience to their digital services. They really wanted to continuously uh, improve it as much as possible, and to improve the level of automation that they are currently providing, so as to gain more experience, and in terms of so as to improve more on the customer experience, and also to attract more customers and the user base. While these are the expectations that have been set for us, we being the partner for our clients, with this there are some negative impediments to it. What has happened because of the digitization of every aspect of anything and everything that we use today, the industry has grown exceptionally, and so the IT ecosystem of our clients. It has been getting very complex, with number of discrete systems being interconnected, integrated together. And uh, and due to this, what has happened, that the negative consequence of this is that we are unable to keep a tap on the overall performance of the system, though we are able to keep a tap on the individual discrete systems, if whether they are working properly, they are up, or they are not working. However, it is we are losing on the overall unified view of it. And because of this, what happens, that any critical system, imagine if it goes for a down if it goes down for a couple of, let's say, few seconds or few minutes, what will happen? It's like a disruption. It's like a disruption, and this will lead to a lot of unhappy customers, and so are our clients. And with the latest survey that has been done in 2022, it says that uh, lot of negative impacts that has happened to the various the enterprises, that some of them had made a big damage to their brands. There has been lowered, their stock prices have gone down. Some of the small to medium scale enterprises, they have actually shut down because of no business. And all these things, they have happened because they couldn't keep a tap on or reduce their resolution time of any disruption that has happened. Let it be for even for the few seconds or few minutes, but they couldn't recover from this. Their systems couldn't recover from this. And when we looked at these numbers, which is being displayed on the left hand side, the graph, the chart, that we tried to deep dive into this problem, and what we observed is that there are a lot of challenges that these systems are going through. One is, they have their monitoring systems, they are very fragmented, they are running in silos, they do not have a visibility of the complete ecosystem. And that's where the opportunity grows for the observability. What observability deals with is, while the monitoring deals with observing the individual systems or monitoring or looking at the individual systems, whether they are working or not. Observability help us to get a full unified view. And so with this solution, we are kind of contending to the market and to our clients that with this foolproof solution of having a full stack observability, we shall be able to help you to come over with the challenges that you are facing today. And yeah, with this data, let's see about how the evolution of this full stack observability has happened and what was there previously in the market. Sorry, Maitreyi, I'm not looking at the chat. Please feel free to stop me if there are any, pressing
Sure,
questions. Yeah.
sure, I'll let you know, Manik.
Yeah. So let's see about the evolution of the full stack observability. And before that, let's see what is observability. So this is a step-by-step approach that whenever, we are trying to achieve an operational excellence for our business, it is very important for us to ensure that our systems are highly available and they are in good conditions and performing to the expected scale. And that's where we try to monitor, we try to continuously observe our system. However, is monitoring sufficient to to avoid any kind of problems? Looks like no, because that was a solution that we have been following. And what typically the monitoring does is it monitors, or it kind of keep a tab or a check on the individual systems. And we what was our focus long couple of years back was whether the system is working or not. Is it up or is it down? So if my system is working, I'll give a signal as my system is working, it is green. And if the overall ecosystem is not working, it is not my problem, because my system is working and my job is done. So we have been kind of restricting ourselves to not look at the overall picture of the enterprise. And that's where it was very important for us to move on to the next level of, or to deep dive further into a better solution than doing a pure monitoring. And that's where we move on to you know a level up called visibility or an observability. Now what it does is, the while monitoring was majorly looking at the passive data or logs and the metrics about it and checking if my system is up or not, visibility and the observability era, it majorly looks into the active data, the real-time data of it. It used to inject the real-time and an active data of telemetry. And with that, I used to continuously monitor the performance of my system. Okay, so remember the difference. The monitoring, it only checks about whether my system is working or not, while our second solution called visibility and observability, it also checks about how is my system performing. Is it meeting the required thresholds? Is it following the required KPIs or not? And here the major KPI was the performance. However, there was another problem that was aligned to this solution. And the problem is, we have numerous solutions for infrastructure monitoring. We have solution for security monitoring. We have solution for network monitoring and the check. However, all these solutions were confined to their respective domains, and they were confined to their respective verticals. And that's it. So still, they our solution is still dealing with the discrete systems, and it is not possible with the visibility and observability to get a full stack solution or a unified view of my overall enterprise ecosystem. And that's where full stack observability comes into picture, which helps us to get a unified view, a single pane of glass through which I can see my overall enterprise ecosystem, and not just the discrete systems or the integration points. So this full stack observability, it is not limited to the application or the infrastructure area or the synthetic monitoring, but it combines all these three aspects together, correlates it, draws some insights, draw the inferences out of it, and also provides us the tangible actions that, you know, my operations team should take when there happens any disaster or my system is not performing to the expected level. So I'll take a quick pause here, just in case if the concepts are clear, or we do you want me to quickly reiterate? So I think, yeah, I take it as, we can move ahead. Now let's quickly understand the pyramid of maturity in terms of the observability and monitoring and why they are different. Remember that the observability is not monitoring. There is a huge difference between a monitoring and an observability, and let's see what are the parameters and the foundation ground on which the monitoring works and observability works. So one step back now, let's understand that there is a problem in our ecosystems and we wanted to troubleshoot it. There occurs some error and my system is down, or my website, the application is not working. It's a very bad experience. The customers are already logging complaints around it. And now what happens? The system, your operations team will go through a cycle of first detecting the problem, then starts the identification and the analysis, and then after the identification, the analysis of the problem, they will try to fix the problem. Now, while it goes through all these three stages of first detection, identification, and fix, which are kind of the manual cycles, and all these three phases are very typical waterfall fallish kind of. What happens is we waste a lot of time in our turnaround time is very high, and we lose a lot of time in identifying the root cause of it. So uh, you know what happens? So while we have a typical case of monitoring where our input to our monitoring system are the system logs, the metrics, the default metrics that the individual systems are providing, and the traces. We kind of, since my system is down, I kind of get an alert from the monitoring and the alerting system via an email or a message, and that's where my detection phase start, that there is a problem and that has been detected. Now the next is what happens, that we move to the identification phase. Now in the identification phase, what happens, that all these feeds in terms of the logs, metrics, and traces that we have received, your operations team starts analyzing it and try to look at the logs from the system. And that's where the things get really hazy, because there are many problems. While the operation team looks into it, first problem that we typically face real time is this team may not have access to all the systems that are participating to your overall enterprise ecosystem, so they have to rely on some other teams to get access, or troubleshoot the problems. Second is they might not have that level of skill set or the expertise to debug or analyze the problem. And because the access is not enabled, and lack of skills, it makes it very, very hard to understand the problem and even to reach any solution for the problem that has been detected. So what happens next? Now because of the lack of the available systems and the correlations and the insights which we couldn't draw, all these things happen in pretty much manually. And that's where the mean time to resolve the problem gets very uh, long. That's where the time it takes the operation team to resolve the problem is very, very high. And with this, once we receive the data and all, because the most of the process we do not have those the kind of the tools that are expected to help us to correlate and draw insights from this data are not available. uh, it is a long process to detect and resolve the problem. And that's where the observability comes into picture, because today what we are talking is about, we are going to discuss about many lot of tools that AWS as a cloud service provider provides us out of the box, and that could be leveraged to help us to resolve the problems much faster compared to our old ways of doing it. So that's where is the difference between the monitoring and the observability. That observability is about monitoring it. It keeps on monitoring the system and just detects that there is some, identifies that or raise an alert that there is a problem in your system, but it doesn't tell us how to solve this problem. Okay. um, so the next is moving on to what is observability. So there have been a lot of definitions being put forward by the industry leaders in terms of the observability and why it matters. So as we have been discussing, it matters a lot because it helps us to really improve on mean time of resolution for our various teams who are currently working on the production issues, be it an operations team or DevOps team or developers, in order to improve the developer experience. It helps us to automate the overall process of identifying the problem, generating the alerts, and identifying the problem, reaching to the root cause and fixing the problem. So yeah, that's where the observability comes into picture. And uh, yeah, I'll take a pause here if there are any questions.
I think we can go ahead, Manik.
Okay.
We don't
Okay,
have any
great.
questions for now.
Okay, great. So yeah, so what I'll just kind of try to read it out for you guys. So what observability says, it's the ability to understand and manage the performance of our system, service, and applications and their resources uh, that comprise of our overall enterprise technology stack. So in nutshell, it helps us to get a unified view of our overall system, and it combines all the logs, metrics, and events that we capture otherwise for our individual and the discrete systems, and it helps us to get a very unified view of it. So now next, what are the main pillars of the observability? We call it as MELT, meaning metrics, events, logs, and traces. So a combination of all these four pillars help us to strengthen our observability. Through metrics, what we do is, these are the discrete actions that we continuously monitor and capture as a record of our health and the performance of our application. Then we have something called event, which is an important pillar, which keeps on capturing our discrete actions, what is happening at any point or any moment of time in any of our systems, not just one system or two systems, but all the participating systems. All these events get captured runtime and in an active mode. Next, we have the logs. Logs are nothing but the record of events and the warnings, anything happening, good, bad, warnings, everything is captured in the form of a record. And that's nothing but our logs. And the traces are nothing but a chain of events that help us to draw some, meaningful inferences out of it. And the traces are really very important, just to emphasize, because today in a distributed system world, since we perform the monitoring of our system at an individual level and as well as at a distributed level, it really helps us to arrange our logs and the our metrics in a orderly manner in terms of the time, so as to draw the inferences out of what we are reading in terms of, be it logs or metrics or the events. So it's very important to have a meaningful trace or an ordered trace of our events and the logs that we have captured. So these are the four pillars of observability: the metrics, event, logs, and traces, and they all function in a group any single pillar won't be useful for us to drive a very meaningful observability solution. Hence, all these four pillars are important, and they have to work in a collaborative manner in order to drive some meaningful information out of the data that we are capturing. So next comes the concept of full stack observability, and why it is again important. It is, as we have just seen, that full stack observability is very important because with with our clients and the end users demanding more and more digital experience and all, it is also very important to track what customer thinks about, you know, your ecosystem, what customer thinks about your application, how is the overall experience you as a service provider serving to the end user. And that's where it is very important to monitor and gauge the metrics and um, the events in terms of the end user experience, and that is something we called as outside in. So the full stack observability has two strategies. One is outside in, where we look at the, you know where we look at the overall system performance from outside in, meaning from a customer, the end user perspective. And there is another way of looking at it, which is called a inside out, wherein we are looking more from, how the systems are performing, how my integration components are performing, how are the individual systems are performing as an individually, and when they are combined together to provide some aggregated outcome, how are they performing. So there are two strategies of doing the full stack observability. One is the outside in, meaning a end user perspective, and another is a inside out, which is our legacy way of doing it, where we keep on observing our individual systems and their performance and trying to gauge the performance and the availability of our system. Now, this diagram, this is a very high level diagram of a typical end-to-end digital application, I would say, wherein you have the end user who is trying to, your portal is a grocery shop and who is trying to buy some, few items from your grocery shop, and is at a moment trying to do a checkout. And post checkout of the cart, the user wants to do the payment and do the complete the order placement. So that's where being a multi-level multi-layered application, you have provided a system of engagement through mobile and the web app, and your application is internally interacting with multiple layers of your application framework. First, through the API layer, you have multiple tech components which are either interacting in a either sync or async mode. You have a middleware system, and you have number of other external system or a third party system with whom your application is interacting with, and you have an end database where which is being used to store the record of data. It's a very typical system. Now, when we look at it from an outside in perspective, from end user perspective, so what a good observability mean for the strategy? A good observability mean for this strategy is that, my overall application is performing excellent. It is not taking time to load the pages. It is not operating slow. The overall checkout process or a usual user transaction, be it checkout, be it payments, they are very seamless, and there has been no latency observed in the overall operations. That's where we will say that, it's a good end user experience. And what is my inside out strategy looks like? So I have many discrete systems which we have already discussed about. So I would be taking a tab and I'll be observing my individual systems if they are performing correctly, whether my database is responding correctly, is there any congestion, is there any traffic, whether my database is performing my queries slowly, how is the API's response, what is the response time, are my system uh, expecting or too many requests coming in? Is there a throttling to my systems or to the APIs? Is that something? All these set of parameters is something that I'll continue to observe through my inside out strategy. So just to brief on this particular slide, outside in is about end user performance, end user experience, that my system is performing well in terms of the parameters or which are related to the end users. And inside out is where it means a lot. While I'm observing my systems or the overall ecosystem, the individual systems should perform well. They should be available. They should perform to the expected level of thresholds. And while I'm integrating all the systems, there are no troubles or there are no any loose links that have been observed in the system. And that's where the full stack observability plays a great role. And now, with this particular scenario, let's get into understanding about what all the offerings that AWS as a cloud service provider gives. So, of course, like many other cloud service providers, even AWS has a very foolproof solution for the observability, full stack observability, or a complete lifecycle management of your enterprise. And that's where it provides a set of tools which help us to derive the overall very competent observability solution. So typically, I would like to, while this is not a complete list of the tools and the offerings provided by AWS, but I'm just giving here a very high level view, and we will deep dive further in the next sections on each and every tool. So typically at a very high level, these tools are being segregated into the collections, aggregation, and the visualization. So a set of tools will help me to collect the data, the telemetry data through various sources, through various data sources. There will be a set of tools which will help me to aggregate and combine, orchestrate all this information which I am receiving through the collector, and draw some meaningful inferences out of it. And then the third thing is, after I contextualize my aggregated data and has drawn some insights out of it, the next thing is to visualize and project it as a dashboard, so that it is very easy for any layman or operations analyst to understand and quickly in terms of my system's health check. So typically, these tools have been divided or segregated into three areas, which is nothing but a collections, aggregation, and the visualization. Now, how shall we set up an observability solution for any ecosystem? What are the steps to it? So first is, as I said, let's correlate this visual with the left-hand side, details. So the first is, you have to set up an instrumentation system to collect your everything: logs, metrics, event traces. Next, you push this data to your aggregators so that they can read this data, they can analyze this data, and can draw some insights out of it. And once the insight engine converts or filters the raw data and bring out the meaningful business insights out of it, let's project it in terms of a visualization board called dashboard, where your operation teams or all those various teams like SRE team, the DevOps team, can see it and can act upon those visual insights. So now let's deep dive into the AWS stack and the various service offerings that it provides for as a observability solution. So the first is about the CloudWatch run, which is called a real user monitoring. So this is nothing but providing a very it helps us to provide a very meaningful experience and a great experience to the end user. What it performs is, you could even relate it to our something called web analytics. wherein we try to continuously monitor and observe the customer behavior. It is nothing, it is very similar to the customer behavior tracking systems, wherein we continuously observe the pattern and the behavior of the customers and or the end users, and accordingly collect this data and take a continuous and take a required actions or the appropriate actions if something is not right. And that's where the CloudWatch RAM helps us to perform the real user monitoring. It does it at the client side, and it is typically the end user monitoring system, wherein it kind of tries to track the customer behavior, whether the customer is happy with the experience or customer is not happy with the experience. What are the what are the inclinations of the customer? Is customer is more inclined to pursue or a particular offerings, or whether customer is not happy with the experience that he or she got on our website. That's where this comes into picture. The CloudWatch is actually deployed as a web client at your customer end, or it could also be fed in a asynchronous manner while your customer is browsing through the website or your application. The next comes the synthetics. What it does, it monitors your system. So typically the real user monitoring, the CloudWatch RAM is for the end users. So it is typically a tool, you can say, which is more aligned to the outside in strategy. And synthetic is something which what it does is it helps us to perform or do the monitoring of your services, APIs, the middleware systems, etc., by introducing a script which runs on a schedule intervals, and it captures the data in terms of your service availability, API availability, the health of your APIs, the response time, the latency, if at all it exists for your APIs. So synthetics is a tool you can relate to the outside in inside out strategy. The next comes the service lens. Now service lens, what it helps is, it helps us to strengthen the observability solution by applying and aggregating all the logs, metrics, etc., which are coming through various individual systems. It helps us to aggregate it, orchestrate the whole data together, aggregate, draw the meaningful outcome out of it in terms of the service map. And that service map is nothing but a very visual board through which you can easily infer that suppose my one of my offering is I want to get a product detail page, and that product belongs to multiple systems through which I'm getting those the list of products. So here my more than one systems are interacting with each other, integrating and correlating the data together, and finally projecting an aggregated view to the front end. And that's where service lens will help come into picture, because it will exactly give when my first call has happened, when my second system got called, what was the time lapse between first call and the second call, and if at all the overall response time of this one single call of providing the details of the product page is not within the requested KPIs. It will help us to easily identify where the problem is, which system we should troubleshoot in order to solve the problem. The next is evidently. Evidently, you could relate it to a kind of A/B testing. A very similar. It is very similar to how we perform the A/B system, A/B testing. So what it helps us to it helps us to safely validate, or first of all, it helps us to release the features in an incremental fashion, and while we release or while we deploy any new feature, it helps us to make it available only to a percentage of users, get their feedbacks, and based upon the feedback, which is positive or negative, we will either increase the percentage of traffic that is being diverted to this particular feature, or we will reduce it in terms in case the performance is not satisfactory. So think of evidently as something which helps you to incrementally release the features, and very similar to the A/B testing pattern. The X-ray service is, it helps us to perform the distributed tracing of a complex ecosystem. And again, it helps us to filter out the meaningful information out of the raw data. Now, overall to that, the foundation is nothing but our CloudWatch service, which helps us to, perform everything: the monitoring, alerting, insights, and the dashboard. This provides us a basic dashboard, which will help us to, understand the system in terms of CPU usage, memory usage, network traffic, etc. However, wherever you wanted to go one level up in terms of, deriving some more meaningful context for your application, or building some customized metrics for your system, uh, we need to take help of these advanced tools, like as I talked about, is like CloudWatch RAM, synthetics, service lens, X-ray, etc. Moving on to the next set of tools and the services. Next we have is a distro for telemetry. Now, as this particular tool helps us to basically collecting the metadata of information, and the more and more systems are feeding in the information to this, this tool helps us to order it in a sequential manner, and pass it on to the aggregation layer. Next, we have, I'll talk about the managed services a little later, but let's first see the core services provided by the AWS. One is the Metrics Explorer. The Metrics Explorer, it is another open tool wherein, it helps us to project and visualize our dashboards. Again, it's a very basic dashboard. The more enhanced dashboards, if you need to prepare for yourself, we'll have to customize it, or we will have to go for more better solutions, like, let's say, Grafana. There is another service offering that we have in AWS called Insights, and this is a very important service offering provided by the AWS, which helps us to collect, aggregate, and summarize your metrics and the logs from various individual services that have been offered by the AWS. So these are very dedicated services, insights, which are confined to the various service offerings from the AWS. So now today, if we move to the AWS stack, or we wanted to move our workload to the cloud, we typically go with a modernization or a re-architect path, and that's where we mostly leverage the managed services offerings of our AWS, be it EKS, ECS, or the Lambda, the lightweight things, etc. And that's where this insight service comes into picture, that if you are deploying your workload in a containerized service called EKS, the containers insight service will help you to monitor and observe the overall health, because the container the container framework itself is very complex, and it consists of multiple layers, and so where the single solution or a single monitoring system may not be of much use. And that's where these insights services are helpful to us, which are very specific, which are built for a specific usage and a specific purpose, in order to provide the insights and meaningful information for particular services. So the container insights helps us to get more insights from the EKS service. The Lambda service, Lambda insights, is aligned to the Lambda service, the contributor insights help us to basically, try to gauge from where the highest traffic is coming from. So let's say you have an ecosystem which is centrally deployed, and you have now you have deployed your thing as a software as a service, and there are a lot of there are a lot of applications that are relying on your service. And let's say on one fine day, one of the application is sending a huge traffic to your SaaS offering. And that's where this contributor insight will help you to gauge that where is this heavy traffic coming from. And so that the simple solution in those kind of scenarios is to block the incoming traffic from that particular application, and let the other services or the other applications continue to use your SaaS offerings. So that's where this service is very, very useful. The X-ray Insight service, it's an offering, or it's a capability which sits on top of the X-ray service, which is provided by AWS, and it helps us in a distributed tracing. Now, coming to the managed service offerings called Prometheus and Grafana, I'm sure you would have used the Prometheus and Grafana. It's typical an observability solution that we use on premise. It's the famous is the Elk stack, the Elasticsearch, Kibana, and the Grafana Prometheus stack that we use in order to again collect, aggregate, and visualize our dashboard and provide a single pane of observability solution. AWS has provided a managed offering for Prometheus, and the advantage of using the managed service offering provided by AWS compared to the Prometheus as an individual solution is you really do, because it's a managed service provided by AWS, you really don't need to take care of the lot of responsibilities have been taken care by AWS, and it's just an a plugin that you need to integrate and get going. Same with Grafana, which is typically used for visualization and analytics and visualization platform. Very similar to the Grafana service that we use. Here, the advantage that has been provided by AWS is it helps us to, irrespective of where your workloads are deployed, whether it is on cloud or on premise, it is easy to integrate these services on irrespective of where your enterprise is deployed. So this is an overall stack of your observability services. Now let's relook at the scenario that we have discussed, and let's see if we can apply how we can apply and what all tools we can use amongst the AWS stack that we have just discussed. So I'll take a quick two-liners in order to describe the scenario. We wanted to observe or build an observability solution from end user perspective as well as from the system and the components perspective in order to help our operations and the SRE teams in order to continuously observe and maintain the high performance and the availability of our overall system. Our enterprise solution consists of multiple layers, starting from a system of engagement through mobile and the web application, and under which we have an API layer which interacts with the underlying middleware systems and the end systems, which are nothing but couple of document storage as well as the database system. Now, when we look at the end user perspective, meaning the outside in, let's see what all tools from AWS stack we could use. So the overall foundation is CloudWatch, which typically provides the foundation services in terms of the CloudWatch metrics, logs, and CloudWatch metrics, logs, and the dashboards. Yeah. So because it's an end user perspective, it is very important. One of the service which could be helpful for us is a CloudWatch run, because it will continuously keep track on in terms of the customer behavior and the analytics around it. The synthetic service will help us to observe our underlying APIs and the services that are that are contributing to overall our enterprise landscape. Next, we will also use CloudWatch Evently service or a tool in order to enable our enterprise to release the features in an incremental manner, get the feedback from the customers, and based upon the feedback from a percentage of customers for whom this service is enabled, we could we could either turn on or off this new features. So these are the tools that we could typically used in order to enable an outside in kind of an observability solution. um, Next is, we would definitely need an X-ray in order to have capture all the logs, traces, and the events that are coming through various sources of information, and we will feed in that into our CloudWatch metrics, which will help us to analyze the basic metrics which are being inbuilt as a part of a CloudWatch solution. And we will also build a dashboard, and on top, if we require any enhanced dashboard, we'll probably go for more enhanced solution in terms of, let's say, a metrics insight or a explorer kind of the solution. So typically, when you're looking from outside in, the important services of AWS stack that we could leverage are CloudWatch RAM, Synthetics, CloudWatch Evently, and of course the foundation, AWS X-Ray, along with the CloudWatch metrics. Now let's look at inside out, wherein the more emphasis is on the individual and the discrete layers of your services, the APIs. How is their availability? How the individual systems are integrating with the collaborating systems and all. And that's where one of the important things. So you are getting the information and the feeds continuously from all these be it the Amazon RDS, the database, the EC2 systems, the Fargates, the Lambda, all these AWS services, the computes, etc. And this all feed in will continuously get into the AWS X-ray, which will help us to perform the distributed trace. And this trace of logs, metrics, and the events will get feed into the CloudWatch, wherein the CloudWatch logs will analyze and draw some insights of it. These insights will be fed in to check if there are any anomalies being detected, and if at all there are any anomalies found, your system will hit an alarm, and which will help us to being to in order to detect the problem and take a appropriate action. So I think the important service which would help us here is obviously the CloudWatch Synthetics, which is I think kind of missing here. But so when we go from inside out, a good AWS stack to build an observability solution will be CloudWatch Metrics, AWS X-Ray, Synthetics, and Insight services, depending upon what offerings you are considering. Out of, if it is a container service, you will go for container insights. If you're using Lambda, you'll go for the usage of the Lambda service. So this is a full view of inside out plus outside in, and these are the services or the offerings from the AWS stack of observability solution, which you will use in order to build a foolproof observability solution. Now let's look at inside out, wherein a case in point wherein we wanted to observe Kubernetes. Overall, the Kubernetes, the overall landscape is very complex because it has got it consists of multiple layers. Like your application is deployed in the containers. You'll have pods which are deployed on the nodes. The nodes will the nodes will reside on the VM. So it is not just one layer, single layer that you will need to observe, but it is the layers, multiple layers, as well as the the overall Kubernetes orchestration and the cluster on which it is deployed, you will have to observe it. And there are a lot of metrics that you will have to continuously monitor and observe in order to ensure the uh, that your system is healthy. So at an app level, you will have to
Manik,
monitor. Yeah.
I'm sorry.
Yeah.
So we have a question. I thought we can take it up now.
Yeah. Let's go
So
ahead.
the question is, can you explain more about install as a web client or through CDN? Because those are two different things, and monitoring it through a CDN. So do you mean
Yeah.
the monitoring is on the CDN itself? Is the question which we have from Samantha today.
Yeah. Yeah, this is aligned to our first service called CloudWatch. So so when I say there are two possibilities to how can we use or install CloudWatch RAM as a service. So one is through the web client. So web client is nothing but it's a typical JavaScript kind of a code that it's a, I mean, I would suggest to relate it through our web analytics way of how we can implement the web analytics for our application in order to track the customer behavior. What we typically do there is there are a set of tags that we embed in our web page, whether it is HTML page or React.js page or Angular page, wherein we embed uh, few JavaScript tags, and using those tracks while the customer or the end user navigates through our web application, these tags you know kind of keep on capturing the data in terms of the customer behavior, whether like say you have multiple offerings on your portal. Let's say you have a lending platform and there are a lot of loan offerings that you have. If a customer is clicking a car loan and probably coming back on home loan, this help us to track whether the customer is also might be interested in getting a car loan, and that's how you track it. So that's one way of tracking the customer behavior, that is through the web client, wherein what we do is we typically use few JavaScript tags which are which are embedded as a part of our HTML pages, or nowadays React or React JS pages, etc. And based upon the customer navigations and the actions on our web portal, we keep on capturing this data. The second way to do is is through the CDN. So you have a nearest CDN, and where you could keep your the cloud RAM solution. And what happens is that within your application, you will continuously keep on tracking the customer behavior and send it as an events in asynchronously to this client which is currently available on CDN. Does that answer your question?
So we have another question.
Yeah.
Don't you think security observability tools also need to be involved in case we think of full stack observability?
Yes, for sure. And yeah, that's a great question. I think I forgot to touch upon those topics. So these the one ground thing about all these offerings is whenever we are installing this observability stack, it has got few inbuilt feature in terms of the who is in terms of the user access permissions and enablements that are already pre-embedded as a part of this solution, meaning the authentication authorization stuff has already been taken care. The second thing is about whether you are falling whether your solution is falling within the guardrails of the compliance and the compliances with respect to your solution. Let's say if it is a payment industry, or you are dealing with the card solution piece, is your solution is compliant to that. So the managed services like Prometheus and Grafana and etc., all these things they definitely take care of security aspect of it as well, because without having that consent in order to expose the data which we are basically getting feed from the external systems and all, we can't really act on it. So yeah, security plays an important feature here. What How to implement it? There are a couple of the basic service level securities are already embedded as a part of this tech stack. Something which is related to the industry standards or specific regulations, we need to gain those we need to gain those consents before start working on these captures.
I hope that clarifies your questions. I think we
Yes.
are
Yeah. So I'll
running
quickly,
out of time.
correct. I think I'll quickly jump on to, maybe quickly in terms of the benefits, challenges, and what lies ahead in terms of the best practices. Yeah. So I think the best practice is something we have already covered. I'll quickly touch upon on the benefits in terms of, as we have been talking through the overall uh, discussion about the observability. It helps us to reduce the mean time to resolve the problems, because it helps us to troubleshoot the problems, auto detect the problems. It helps us to provide sometimes auto resolve or provide suggestions in order to how to resolve the problems as well, because our system is can also be intelligent when it is interacting when it is integrated with the AI solutions, and having a mass of data which has been continuously captured over the years. Your system can learn out of it, and can also provide the faster resolutions, or can provide auto fixes as well. It definitely help us to enhance the productivity here, because that the dashboards and the overall ecosystem is very easy to understand, and very easy to draw inferences out of. So the alerts and the signals that your overall dashboard is providing, they are quite self-explanatory, and in that case you really do not need to rely on have any dependencies in terms of system access, or any technical component access, or even you don't really need to rely on different teams in case you don't you in case you do not have that particular skill to troubleshoot the issues. uh, yeah, the less alert fatigue, I think it really eliminates, because the system has been very responsive and acting very proactive rather than using a reactive approach. And overall, because we are embedding a full stack observability outside in as well as inside out, it will surely help us to improve the overall experience for the end users. Now, the challenges we have with this while implementing the observability solution is, as I said, because as we try to improve our solutions and try to make it more innovative, automate it further, and the complexity of the overall infrastructure is increasing. And that's where it is very important that we put forward the right stack of observability, and we do observe the right systems and the right parameters for those systems, which will help us to troubleshoot the problems in a quite faster. The second challenge we'll continue to have is the increased data and the volume with which it is increasing, because the more and the more systems are getting integrated to your enterprise, the data is kind of increasing in an exponential pattern. So the challenges is some of while the enterprising prices are more moving to have a centralized IT and everything. There are few areas where we can observe, especially in the legacy area, the teams still work in silos. There are individual business units who work in silos, and that's where the observability solution, even if you implement with any good set of tech stack or the tools, it may not be very effective. The next thing is it is very important to identify the KPIs which are aligned to your business and the tech strategy, so that you could derive the right key parameters to be monitored, watched, and measured in terms of the performance. So I think that's where I'll take a pause. In fact, I'll end my presentation here, and we will let's open up if there are any questions. And yeah, with this, I would like to thank everybody for being patient and listening to this discussion and the topic, and I hope it is useful.